All right, we're in the Helicopter Flying Handbook in Chapter 4, page 17 of 18 on iPad or smart device. We're going to be going over Autopilot. Autopilot. Helicopter autopilot systems are similar to stability augmentation systems, but they have additional features. An autopilot can actually fly the helicopter and perform certain functions selected by the pilot. These functions depend on the type of autopilot and systems installed in the helicopter. The most common functions are altitude and heading hold. Some more advanced systems include a vertical speed or indicated airspeed hold mode, an IAS, where a constant rate of climb, descent, or IAS is maintained by the autopilot. Some autopilots have navigation capabilities such as very high frequency, VHF, omni-range navigation systems, a VOR, instrument landing systems, an ILS, and global positioning systems, GPS intercept and tracking, which is especially useful in instrument flight rules, IFR, conditions. This is referred to as a coupled system. An additional component called a flight director, an FD, may be installed. The FD provides visual guidance cues to the pilot to fly selected lateral and vertical modes of operation. The most advanced autopilots can fly an instrument approach to a hover without an additional pilot input once the initial functions have been selected. The autopilot system consists of electrical actuators or servos connected to the flight controls. The number and locations of these servos depends on the type of system installed. A two-axis autopilot control an helicopter in pitch and roll. One servo controls fore and aft cyclic, the other controls left and right cyclic. A three-axis autopilot has an additional servo connected to the anti-torque pedals and controls the helicopter in yaw. A four-axis system uses fourth servo, which controls the collective. These servos move the respective flight controls when they receive control commands from central computer. This computer receives data input from the flight instruments for attitude reference and from the navigation equipment for navigation and tracking reference. An autopilot has a control plane in the cockpit that allows the pilot to select the desired functions as well as engage the autopilot. For safety purposes, an automatic disengagement feature is usually included with which automatically disconnects the autopilot in heavy turbulence or when extreme flight attitudes are reached. Even though all autopilots can be overridden by the pilot, there is also an autopilot disengagement button located on the cyclic or collective, which allows pilots to completely disengage the autopilot without removing their hands from the controls. Because autopilot systems or installations differ from one helicopter to another, it is very important to refer to the autopilot operating procedures located in the RFM. All right, let's go into environmental systems. Heating and cooling the helicopter cabins can be accomplished in different ways. The simplest form of cooling is by ram air. Air ducts in the front or sides of the helicopters are opened or closed by the pilot to let ram air into the cabin. This system is limited as its required forward airspeed to provide airflow and also depends on temperature of the outside air. Air conditioning provides better cooling, but it is more complex and weighs more than a ram air system. One of the simplest methods of cooling the helicopter is to remove the doors, allowing airflow through the cockpit and engine compartments. Care must be taken to properly store the doors, whether in a designed door-holding rack in a hangar or if it is necessary to carry them in the helicopter. When storing the doors, care must be taken not to scratch the windows. Special attention should be paid to ensuring that all seatbelt cushions and other loose items are stored away to prevent ingestion into the main or tail rotor. When reattaching the doors, proper care must be taken to ensure that they are fully secured and closed. Air conditioners or heat exchangers can be fitted to the helicopters as well. They operate by drawing bleed air from the compressor, passing it through the heat exchanger, and then releasing it into the cabin. As the compressed air is released, the expansion absorbs heat and cools the cabin. The disadvantage of this type of system is that power is required to compress the air or gas from the cooling function, thus robbing the engine of some of its capability. Some systems are restricted from use during takeoff and landings. Piston-powered helicopters use a heat exchanger shroud around the exhaust manifold to provide cabin heat. Outside air is piped to the shroud, and the hot exhaust manifold heats the air, which is then blown into the cockpit. This warm air is heated by the exhaust manifold, but is not exhaust gas. Turbine helicopters use a bleed air system for heat. Bleed air is hot, compressed discharge air from the engine compressor. Hot air is ducted from the compressor to the bleed air heater assembly, where it is combined with the ambient air through an inducted port mounted to the fuselage. The amount of heat delivered to the helicopter cabin is regulated by a pilot-controlled bleed air mixing value. All right, we'll hold off there. That's page 17 of 18, and got a little bit into 18 there. So that got into Autopilot, environmental systems. And now we'll go into page 18 of 18, anti-icing systems. See ya.